Yep. Hi, everyone. Good morning. Thank you for being here. My name is Dan Taylor, and I'm a program manager for our Python developer tools here at Microsoft. And I'm very excited to be here today to help you get productive in your developer workflows using Python and using the developer tools that we have at Microsoft. So I just wanted to start by asking how many people here are currently using Python? Almost everyone. Anyone here not using Python but here to learn more about it and want to get some experience? Wow, that's quite a few of you. Is anyone here? How many people of you who are currently using Python? How many of you just started recently? All right, so a good chunk. So a lot of people in all three buckets. So I'm going to try and share a little bit about Python and a little bit about our tools to help you learn how to get productive. Now, I know everyone here, you're all productive people. Do you know why? Because you're interested in Python, yeah. Any other guesses? You're here at 8:30. There we go. Yes, you got it. So thank you all for coming here at 8:30. I really appreciate it. So today we're going to go through first an overview of using Python, and including Python at Microsoft, just some little bit background information about Python, the language itself. And then we're going to go through an in-depth tour of using Python and Visual Studio Code. And then we're going to take that and show how you can use Python with VS Code to target Azure. And then we'll wrap it up with a tour of Python in Visual Studio, particularly for mixing Python with C++. So let's go ahead and get started on the overview of Python. So I don't know how many of you have seen some of the information coming out of Stack Overflow, but Python is actually currently the fastest growing mainstream language, according to the most recent developer survey. So it's used in the 2018 Stack Overflow developer survey, 38.8% of developers indicating that they're using Python. And if you look at the language growth year over year, it's grown in 2017 and 2018, 28% and 21% year over year. So it's got a huge share, and it's continuing to grow really quickly. And if you actually look on the Stack Overflow blog, they've got some really interesting articles about what's driving this growth. But you can also see by the tags searched on Stack Overflow, it's also the fastest growing language there in terms of people interested in learning and wanting to get help using the language. And so what are people using Python for, right? So there's the Python Software Foundation actually put out a survey recently. And from that survey, we can see that of people who said what their primary purpose for Python is, we see 27% of the survey respondents said that they're using data science or machine learning. Anyone here, data science, machine learning? Looks like about 27%. Web development with, like, for example, Flask or Django, very popular web development frameworks. Anyone? Okay, much less than that. Scripting, testing, automation. So that seems like it's the majority of the people here. And so that's really a lot of the getting productive part about using Python is you can script a lot of stuff together. A lot of people use automated tests or maybe just automating downloading files, moving things around, or IT administration of a lot of machines out there in the cloud. So the link to the Python Software Foundation survey about Python's here. There's all sorts of interesting insights about what people are using Python for there. I encourage you to search about that and check it out. So Python at Microsoft. So we actually have a really long history of working with Python at Microsoft, but today we've got sort of three main areas that we're investing in. So first is the Python extension for Visual Studio Code. And so we think that this is generally the best place to start for general purpose light Python development. It's very lightweight. It's cross-platform, and it's a fully open source. So that means you can use it on Mac or Linux or Windows. And then we've got the Python workload in Visual Studio. So if you're an existing Visual Studio user, this is the best place to start for you. You're already familiar with the Visual Studio environment, and you get a fully featured Python IDE just by installing the Python workload with Visual Studio. And this is especially good for mixing languages if you're using Python alongside C++ or C#, for example. Visual Studio is a great place to be working with Python. And then finally, our Python support in Azure. We've got great support for Python in Azure with Azure Web Apps, Azure Functions. We've got a hosted Azure Notebook service. You can create Jupyter notebooks and run them in the cloud. And then we've got a pretty comprehensive set of SDKs for Python for all of the services. And the Azure CLI itself is actually written in Python. So this is actually driving a lot of the SDK development because the CLI actually needs to use the Python SDKs to interact with Azure. So pretty much anything you can do with the Azure CLI, you can script and automate by importing Python libraries. And then fun fact, Microsoft also contributes to Python itself. We have a bunch of contributors on our team that work on CPython, work on security features, building Python for Windows, actually management of the Python project itself. And we employ more active Python contributors on our team than any other company out there. So we're very happy to be giving back to the Python community. So that was a quick overview of Python. Let's dive into Python and Visual Studio Code. So Python and VS Code, as I said before, it's the best overall tool for Python for general purpose Python use. It's lightweight, it's got really good capabilities. It is designed to be an editor plus command line. It's not a fully integrated IDE. It's designed to be used alongside editor and to be composed with a bunch of other tools that you're using. So it's not a fully integrated environment. But within VS Code, we've got great momentum. Python is the fastest growing language in Visual Studio Code, and it's the most popular extension on the VS Code marketplace if you look at installation count. We've got over 10 million downloads of this extension, and so it's popular and very highly rated. And this extension is fully open source. And actually, this fun fact about this, it was originally created by a member of the community, Don Giamatti, and we actually hired him at Microsoft, and we added a team to the Python extension, and we started republishing the extension as Microsoft back in November of 2017, and we've had about 5 releases of the extension since then, continuing to add new features. Another interesting thing about the Python extension for VS Code is that it's bundled with Anaconda. So the Anaconda is a popular data science platform that's used by more than 6 million Python developers in the world. And so you can easily install VS Code as part of your Anaconda installation. So it's very easy to acquire and get up and running. And so this Anaconda extension pack includes a Python extension as well as some other things for Conda environment, syntax highlighting, and things like that. So I'm going to go ahead and dive in and show you using VS Code and creating doing some basic scripting stuff with VS Code and the command line. All right, so just to get started, I've got my command line here. The first thing I'm going to do with my command line is actually create a folder where I'm going to put my Python code. So I'm just going to create a new folder called New App. And one of the things that I want to show you about is this concept of virtual environments. Anyone here used virtual environments before? So a good number of you. If you're new to Python, this is kind of, it's almost like running npm init or something like that if you're using similar concept for Node. But it's a good practice to create an environment that basically is a copy of your Python installation with a set of packages that your app depends upon. So if you've got multiple Python applications on the same machine, you can create an environment that just has the packages that your app depends upon, and then you can carry those set of packages with you as your app gets deployed to different environments. So to do that on Windows, you actually use this py command line, which if you've ever hit this problem where Python isn't on the path on Windows, there's a Python launcher, py, and you can just type py-3 and that'll launch Python 3. So if you've got multiple versions, you could do py-2, for example, if you want to launch Python 2. So we want to launch Python 3, and we're going to run the virtual environment module, venv, and this is going to create a virtual environment in a folder called env. So this is creating a copy of this Python 3.6.5 interpreter that I have installed globally on my machine, but it's creating just a local copy within this new app folder that my app can depend upon. And once this, so if I right now type which Python, for example, it's going to show that I'm running Python out of this global installation folder. Now if I activate this virtual environment with env scripts activate, and I say which Python, now it's showing me I'm using the Python out of this folder. Right? So now I can install packages. For example, if I want to install pylint, which is a Python linter that VS Code will actually use, I can just type pip install pylint, and that's going to install pylint just for this environment that I'm using right here. All right. So let's go ahead and jump to another folder here that I've already created this environment, just to skip the installation steps here. So sorry, I did that a little bit quickly, but the way I like to launch VS Code is I go to a folder and I type code dot. And that means that code will launch and automatically open up in the current folder that I'm in on the command line. So it's just a useful, productive tip if you want to quickly open VS Code in a folder. So I've got this environment here that I've created. And just to show you here, if you actually expand this environment folder, you'll see the site packages is where all of the packages I just installed. So there's pylint there that I just installed. And the scripts folder has the python.exe is here, right? So that's just taking a little bit of the magic away. I just want to show you some of the guts. You don't really need to dig into this folder. You can, it just needs to be there. You can ignore it otherwise. So I'm going to create a new script, a new Python script with VS Code. I'm going to click this new file icon. Oops, I put that in the end folder. I wanted it here. I'm going to call this stackoverflow.py. So I mentioned Stack Overflow developer survey results before. I thought it'd be fun to actually create a script that downloads the raw data for Stack Overflow survey and actually do a little bit of analysis on it, and just to see if we can reproduce some of the results that we saw published on the slides. So the first thing I'm going to do is actually download the Stack Overflow developer survey from their website. So developer survey download. So they actually publish the raw CSV files for all of their surveys every year. So I'm going to go to this here, and I'm just going to grab the link from their website. So I've got the CSV file for 2017. I'm just going to copy this link. OK. So to download the survey, I'm going to use the request library. So in Python, to import a package, you just type import and the name of the library, requests. And when I hit save, VS Code should kick in and give me a linter warning here in a minute. Oh, sorry, I forgot one thing. Right now, VS Code is set to use this global Python interpreter here in the status bar. So you can click on this status bar and actually pick which version of Python you want VS Code to be using. So I'm going to select that environment that I just created here by selecting this Python 365 env. All right. So now when I hit save, pylint kicks in, and it tells me that this unable to import the request library. So I need to actually install the request library into this environment. So one neat thing, I mentioned that there's a command line. I was using a command line outside of VS Code. VS Code has a built-in command line that we can use. And to open it, I'm going to go Control-Shift-P, which is the command to run the keyboard shortcut to run a command in VS Code. And I'm going to use this Python create terminal command. So when I use the Python create terminal, it'll actually activate that environment that I just created. And it sets me right there in the command line so I can start using Python here. So I'm going to use this terminal to install the requests library, pip install requests. So that will go download the package from the Python package index. And then now that it's installed, if I save this file again, that pylint runs again and that error has gone away. All right, so let's download this file from Stack Overflow. So I'm going to say request equals requests.get, and I just put this URL in there. So that will create a web request to download the file. And now I need to save the file. So Python's got a really nice file API. And to save the file, I can just type with open survey 2017.zip. So I'm opening a file called survey 2017.zip, and I'm going to open it for write as a binary. And we'll just say as file. And the reason I'm using this with syntax is as soon as I get out of this with block, it'll close that file automatically for me so it's not left open. And I'm going to say file.write request.content. So you notice as we're typing here, we're getting various syntax highlighting and IntelliSense and things like that. Sorry, 1 second there. I'm stuck within the right syntax. So I get IntelliSense built into VS Code so I can see all of the members of this request object, and I can select request.content. Okay, so I've written a piece of code to download the survey as a zip file. Let's run this. So to run code in VS Code, you can simply right-click on any Python file that you have and select Run Python File in Terminal. So that will create a terminal, activate that virtual environment, which has the request library installed, runs the Stack Overflow.py, and downloads the survey into a zip file. Cool. Now we want to unzip this survey. So Python's got a really rich standard library. It's got built-in support for zip file. So I can use the zip file package to do this. But I've actually got, instead of writing the code out for this, I'm going to use Python snippets here. Let's hold on. So I've got a bunch of code snippets that I've pre-created here, and they've added to my IntelliSense. So if I just type this so unzip tab here, it's going to just insert that code for me. And you can parameterize these too. You can put different variables in them or things like that. And to modify your snippets, you just go to File, Preferences, User Snippets, and then pick the language, Python. And then you can see here I've defined that so unzip snippet, and I've just defined the code here. There's additional syntax you can put for parameterizing these as well, if you find yourself writing the same code over and over again. Okay, so now I want to unzip the file, but I don't want to rerun this whole script because I'm going to make everyone here wait for me to download the survey again. So I just want to run this block of code. So to run this block of code, I can simply highlight it, and then select right-click, run selection or line in Python terminal, and that just opens the Python REPL there, pastes that code in, and you can see we've unzipped that survey into this folder, and we've got the CSV file here. Okay, this is a little bit messy. We've got zip file folder. There's a PDF here. Let's clean this up. The only file we really need is this survey results public.csv. So let's write a little bit of Python code just to extract out that CSV file and delete everything else. So I'm going to use another snippet, so cleanup that I have here. Press Tab, and again, this time I'm going to press Control Enter. There's a keyboard shortcut to run this in the terminal. Control Enter, and that goes ahead and it pushes that into the terminal. And there I'm left with a nice clean survey2017.csv file. So that was just lightly scripting stuff in a Python file. You can create a Python file, put some stuff in it, run it, very ad hoc. That's something you can do. Now, if I want to take this and turn this into a function, I can use the refactoring feature in VS Code. So I'm going to close this terminal. So to refactor, I can select this full block of code here, right-click, and say extract method. Okay, fine, I'll save. Oop, didn't have the rope library installed, but we just quickly need to install a refactoring library. As I mentioned, VS Code brings together a bunch of different packages that you can use. So refactoring is powered by rope in this case. So now we can right-click and say extract method again. And let's name this download underscore survey. Press enter. And if I had a bunch of other code that was depending on this, then it would rename other things. So there, it's created a method, and then it just calls download survey for me right there. Cool. All right, so that was just an introduction to kind of scripting with Python, getting your environment set up and things with VS Code. And just to recap, we saw how you can select an interpreter with VS Code, run a file in a terminal. You can use linting, code snippets, running just a selection in the terminal with Control Enter, and then finally refactoring. And by the way, all this code, if you want to play with it yourself, is available on my GitHub account, Cubitron. Again, my name is Dan Taylor, which is a very popular name. So there was actually 1.8 Dan Taylors at Microsoft, and one of them was on the same floor as me. So I have to be creative with my GitHub names. Okay, and just a quick recap on virtual environments. Some people struggle with this concept a little bit, so I want to just share the code with you here. If you want to create a virtual environment, on the left-hand side, that's how you do it on Windows. On the right-hand side, if you're on Mac or Linux, these are the commands you're going to want to use. And then to install packages, you just say pip install, put a list of packages there. Or if you have a requirements.txt file, which is typical for a GitHub repo, you can just use pip install -r requirements.txt to install all of the packages your app depends upon. And at any point, if you want to save a package list, you can just run pip freeze and then pipe that out to the requirements.txt file. And then finally, always remember to deactivate. If you ever need to get out of that virtual environment, you just run the deactivate command. Cool. All right. So we've downloaded this CSV file with some lightweight scripting. Now let's actually go in and analyze the file a little bit and see if we can get some information out of the data that we have stored. A second here, let me switch back to my demo machine. So I'm going to switch to a more fully featured version of this code where I'm going to go to the Hello Stack Overflow folder here. Again, type code dot, press enter. It'll open up the code here. And I've taken that code that I've just written, and I've expanded it out to work with multiple years. So I took the URL manually and pasted it, but here I've created a dictionary that contains all of the URLs for all of the surveys going back to 2011. And then within each survey, there is different file names. That the CSV file is stored in that zip file in a different location, different file name. And then the question that's actually asked on the survey each year is changed. Right? So I just put this information in some handy dictionaries here at the top of my file. And then I've got some methods here. There's the download survey method that we wrote. And then I've got some code here that actually goes in and analyzes those CSV files. To show you how this code kind of works for analyzing the languages that people have responded on the survey, I'm actually going to use the debugger in VS Code, and we're going to step through this line by line. Okay? And just get rid of this code. So to use the debugger, you can just click on the left-hand side in the margin here, and you can set a breakpoint. So that means that when I start the debugger, it's going to stop on this line of code. You can also press F9 as a handy keyboard shortcut to set and unset breakpoints. Okay, so to start the debugger, you can click on this debug tab, and you can just press this play button to start debugging, or you can press F5, handy keyboard shortcut. If you've used the Visual Studio debugger before, VS Code has all the same debug shortcut keys, so it's very familiar if you're a user of Visual Studio. So we've actually got two debuggers here. We've got Python and Python Experimental. So Python Experimental is actually a new debug engine based on the open source PyDevD debug engine that we're working on in VS Code. It's going to be faster and more reliable. And it's actually pretty feature complete. So if any of you are trying VS Code, I encourage you to use the Python Experimental version, and it's going to become the default pretty soon. And if you hit any issues, we encourage you to file GitHub issues on our GitHub page and let us know what your experience is like. So I'm just going to select Python Experimental. It's going to start up the debugger, run the app, and we're going to hit that breakpoint that I just set there. Okay, so within this loop, what I'm doing is I'm going for years 2011 to 2017, and I'm just going to get the languages breakdown that's in each year of the survey, and I'm going to throw the result into this totals dictionary here. So I'm going to run one iteration of the loop just by pressing play or F5. So that will run until it hits that same breakpoint again. So you can see it's downloading the 2011 survey, and it's processed and analyzed it. And to look at the results, I can hover over this totals variable, and then I can expand inline here in the browser. I can see the results of all the surveys. So these are the number of people that answered each language on the 2011 survey. And I couldn't actually find the survey results from Stack Overflow from 2011. So if anyone knows how to find that, let me know. But this is the only place I know actually to find the information today. Okay, So that was one iteration of the loop. Let's go ahead and step through this languages breakdown method to see kind of how this works. So let's press F11 to step in. I'll step over this method here. So if the file doesn't exist, it downloads the survey. Okay, so we're downloading the survey. And now we're processing it. So to process the survey, we're using this popular library with Python called pandas. So pandas is a very popular data science library. Basically gives you slicing and dicing operations over tables of data. You can do joins, aggregates, summations, all sorts of things, right? So we're going to use that to analyze the Stack Overflow data. So the first thing we do is we just read the CSV file into this data here, and we can see in our variables window that this is of type data frame. And I've got some special logic here. Before the year 2016, we actually need to go in and pull out a bunch of columns out of this survey. So to quickly show you why, I'm going to open up the CSV file so you know kind of what this data looks like. I'm going to right-click and reveal in Explorer, and then I'll just double-click this and open it with our friend Excel. So these questions on the survey here, it says, which languages are you proficient in? And then it's got, for each language has its own column. So if someone says, I use Python, this column will say Python, right? So basically, we want to get a list of all of these columns here, and then just count how many rows contain each value, if that makes sense. So that's what this code is doing. It's going through the columns until it can get to the question name that we're looking for. So question names 2012 is which languages are you proficient in? That's what we just saw there. And it keeps looping until it gets there. Now I want to skip this loop. And to skip the loop, I could set a breakpoint and run to the breakpoint, but I can also right-click and say run to cursor. So that will just run the debugger right to the cursor. And so now we're adding all of the unnamed columns here. And then we can skip past this, and then we run to cursor again. And now we filter the data just to the columns that have languages, right? So this is a list of all the column names we found. Just by passing in this list of column names, this array index operator actually filters the full set of data down to just a table, another table, this languages table that only contains the list of languages people indicated. So just to show you this, I'm actually going to use the debug console. So there's this debug console in VS Code that lets you evaluate variables. So I can type column names, for example, in here, and this will print out the list of languages. I can say list languages.columns, and this will show me all of the columns that are included in this languages table, and we can see it just contains that. So all of the unnamed columns are these columns here. All right, so the last piece of code here, this is just some indexing code that summarizes all of the counts of values seen. And we just hit F10, and this will summarize that. And then we total it, add a percent column, and return. And then finally, this takes that languages count and turns it into a dictionary, and then adds it to this totals array. So there we go. That added the 2012 list right there. All right, so we're going to let that run until here. Run to cursor. The last thing we do is we just dump this totals array as a JSON dictionary to a file called data.json. And we can see the surveys are downloading here. And we're almost at 2017. Their survey gets more and more popular each year, so it gets slower and slower as the years advance. All right, so we're at that last line of code. I'll press F10, and then this data.json was written out just now. And then and I put some parameters in there to pretty print it so we can see the results. All right, so let's go ahead. So how do we know that I got the right answer from my analysis? Right? So I've got some unit tests written here that will actually check some of the values against the values that we've seen on the Stack Overflow website. So I've defined this test here in this test_data file. And this is written using the unit test library. So to add unit tests, you can use Control-Shift-P and just say Python run all unit tests, and that'll take you through a set of configuration steps here. I've already configured this, and since it's configured, I actually get these really nice code lenses on top of my unit test that lets me run an entire set of test classes, or I can run one test at a time. So I can select, I've got test here to test the percentages. This will basically import this Stack Overflow file here, and simply by having this file in the same folder, I can import it, and then I can call that language's breakdown method for 2015 and go ahead and run it. So I'll click this run test here. Okay, there we go. So now that that ran, I get a little indicator here saying that the test failed, and also in the code lens, it's saying that this individual test failed. So I can click on the failed test indicator in the status bar and view the unit test output. And we see here that for Java, we came up with the answer of 199% of people on the survey indicated they use Java, which is clearly not possible, so we got a bug in our code here. And so I'm going to actually need to debug this unit test using the debug test function, but just to make things fun, I'm also going to use LiveShare, because I didn't actually write this code. My friend John here on my team is a little bit more, he helped me a lot, so I'm going to ask John to come in and help me with this. Now, unfortunately, we had some network issues with the two laptops this morning, so John's actually going to take over my laptop, but you'll see what LiveShare looks like. So to kick off a LiveShare session, I just have the VS LiveShare extension installed. I click the share link, and it will give me a link that it's copied this invitation link to the clipboard. And so imagine if I sent this to John via IM, and then he took over and pressed enter there. He would see this experience.
You see, John would have actually been helpful had his machine been set up before the talk this morning instead of discovering all this other stuff. I had this wonderful repro of a bug on the actual machine I had this set up for. So anyways, so what's cool about what's going on here, right, is that if this was actually my machine, which had none of Dan's code installed on it, the cool thing is let's use our imaginations for a second. What you'll see is all of the code just magically appeared, right? Like, I was like running on a machine somewhere else in the world, different machine, none of the source code on there, but yet what I'm looking at now is Dan's code. And not only am I looking at Dan's code, I am also looking at, I can also kind of direct and interact with the code on my machine, and Dan can follow along, right, to see what I'm doing at the same time, right? So that's the real benefit is if you need to call in a consult from somebody else, you'll have this ability to very, very quickly bring them in with zero context, right? They didn't have to install a bunch of software, they didn't have to install Python, they didn't have to install a whole bunch of other things on their machine. They just needed to have LiveShare enabled on their computer. One other thing that's cool about this is not only I could have, does this work yet, Dan? The VS and VS Code thing for Python? Not yet, right?
It does, actually.
It does?
If VS Code can host and Visual Studio can join.
That's fabulous, right? So we can go cross-platform, so I could be a VS dev, and we can still have these things go back and forth, right? Between two different environments with zero context, right? And I can step in here and help them out. So
let me actually just start debugging here, John,
yeah,
so that you can get right into the problem. So on my machine, I can set a breakpoint here, and I can start debugging this unit test by selecting Debug Test. And on John's side, his machine automatically picks that up, sees the context, and sees that I'm stopped at that breakpoint.
Right. So you saw that it popped up Dan Taylor there in a second. So I can go off and run things on this machine as if it were mine. So this is really my machine. We're back into the imagination land again. So we hit F11, and we're following through. So what you would see on Dan's machine is he's following along as well, right? So he can see. Let's switch back. Yeah,
if we switch to the other instance of VS Code, it's now jumped to that same. It's following where John is taking the debugger.
Right. So as we kind of step through here, one of the things that we want to look at here, let's make this thing smaller, and we're going to scroll down a little bit. The cool feature that we saw earlier is if we come in here and we right click, right, and we go run to cursor, we can run down to a more interesting spot. Instead of kind of belaboring the point about how I figured out what what the bug was, what we'll do is we'll use one of Dan's handy dandy snippets here, and we're going to go run the SO total snippet here, which will magically go fix the bug. So if we save this thing here, now one of the interesting things that I want to point out here is that we're sitting in the middle of a debugger, and I just kind of randomly pasted some code, right, into an active live debugging session. How many people think that's just going to work?
That's a trick question, yeah.
It doesn't work, right? So the thing you got to remember is you have to stop the debugging session, and if you need to go off and you need to start running the thing again, right? So that Python can go off and pick up the changes that you actually had in the file. And of course, we also have to remember to save the file, right? When we did that as well, right? So there's a couple of things we need to do, right? But we're going to save the file, and we're going to go run on the restart button to restart this thing. We're going to get to this point here, and
It's actually a
are we seeing another?
quick bug here. I'm just going to stop and start again. So I'll set the breakpoint,
Down there.
and I'll restart this debugging session.
Yeah, skip over that thing. And we'll run. We're going to keep running. We're going to keep going. We're going to keep going. And then boom. Right, so if we just hit F5, right, to continue, right, we'll see the result of our test. And lo and behold, if you go back to the thing.
If we go back to our unit test here,
It's
We'll
going,
see.
it's going, boom, the checkbox is there, right? So we've now passed the test, right? So the key thing to remember here is you need to stop the debugger, but the cool thing is you can kind of edit the code, right? While you're in there, you just got to remember, right, restart the thing, and everything will be good.
okay. Thank you, John, for your
You're
help. So if you continue using your imagination, he just zipped in some code into my editor from a remote machine. All right. Okay, so just a quick recap there. We saw, doing some data analysis using Python. We went through the debugger. We show how you could start debugging, step through code, inspect variables, type things into the debug console, and use that run to cursor method. Then we used unit testing with unit test integration and VS Code to actually test that the data was correct. And then finally, we combined all three things with live share, unit testing, and debugging, all with one feature set to get help from John pseudo remotely. And again, the code for this is available on my GitHub account. Okay, so that was a pretty in-depth tour of Python and Visual Studio Code. Now we're going to take a look at Python in Azure. So as I mentioned before, there's a few different services for Python in Azure. We have Azure App Services, and really the best way to work with Azure App Service is to deploy Docker containers to App Service for containers. And you can also run Python functions in Azure App Service. We've got our Azure Notebook service, which allows you to create Jupyter notebooks. This is on notebooks.azure.com for easy experimentation and data exploration without having to install Jupyter locally. And then you can share those experiments publicly with other people just by giving them a link. And then we've got Visual Studio Team Services, which allows you to do continuous integration and deployment with support for Docker containers and running Python tests. And then finally, there's all sorts of various data services in Azure. You can use hosted Postgres, MySQL, Cosmos DB, Redis Cache, and all of these things are supported with the Python Azure SDK. Of course, not to mention all of the machine learning services in Azure, which all allow you to use Python-based code. So I'm going to take a demo of taking this app that we've just created and turning it into a web app that's now running in Azure App Service so that everyone can see the survey results that I've just created here. And just so that everyone's sort of following along with the demo, we're going to sign into Azure with VS Code. We're going to create an Azure Container Registry. Then we're going to build a Docker container containing my app, push it to that registry, and then finally deploy that container to Azure Web Apps for containers. All right, so switching back, close off our collaboration session there. So I'm going to switch to another version of this app where I've done a little bit more work called Stack Overflow Flask. Flask is a very lightweight web framework for Python. It's very effective at creating simple APIs and simple web apps. And I'll show you that in a minute. So let's look at the code here. So I've got that same stackoverflow.py file that generates the survey data. The only thing is that it puts the data into this data.json folder that's inside of a web app. And I've got my web app running in this main.py. So this is all the code you need to create a web app with Python using Flask. So the only thing we do is we import the Flask module here, and then we create a Flask app by instantiating the Flask object there. And then we can use that app object to define routes. So for our home page, we're going to return this index.html file. And then for we can also define a data API that just returns that data.json file that we had just generated. And this index.html just has some charting code that will actually show all of the information we just collected in a neat visual chart. So to run this, remember we have run Python file in terminal, right click, run Python file in terminal. That's going to go ahead and run that Flask app, and it's running on localhost. So a really cool thing here in the terminal, there's these links that show up whenever you've got files or other things you can navigate to. So I'm going to control click and open this up here, and there's a neat chart with the data we just analyzed, and you can see Python here has really been picking it up over the last few years. That's kind of what we were talking about earlier, and it's at the 38% mark. Okay, so we want to take this app and now host this on a website so I can share these results with the world, and everyone can come and see what the Stack Overflow data is over the past few years. Okay, so I'm going to Control C here. So I've got a few extensions installed with VS Code that are going to help me do this. I've got the Azure App Service extension as well as the Docker extension. So those two together will allow me to take my Python code, Dockerize it, and deploy it to Azure App Service. So these extensions add some commands. So one of those commands is the Azure sign-in command. So I can run Azure sign-in, and this will actually authenticate my VS Code with my Azure account. And what it does is it just copies this authentication code to the clipboard, and I click this open link here. It gives me this login prompt where I can paste that code, and I hit continue, and I log in with my credentials, this Python demos account, and boom, now VS Code is authenticated with Azure, and I can see that here in this Azure Python demos account. Now that I've got my account created, I actually want to create a Docker container registry. I'm going to need somewhere I can deploy a Docker container to in Azure. So to do that, I'm going to just go to my portal here and select the Create a Resource button here, top left-hand corner, and I'll type in container registry. Hit enter. Try that again. And so I click container registry, I'll hit create. We'll call this Stack Overflow app. And we're going to put it in a resource group. So a resource group is kind of like a folder that you can create that stores all of the resources in Azure that are related to a single app. So we'll call the resource group also Stack Overflow app. Actually, I'm going to name the registry SO registry. So this registry name will appear at Azure soregistry.azurecr.io. So this is an IP or a name that's available globally for anyone to hit. I'm going to enable the admin user so I can. Oh, thank you. That probably would have caused me some problems.
Audience syntax checking. That's
yes.
Awesome.
I got a live syntax checker here in the audience. Thank you. Hit create. That's going to create that registry for me. And we'll actually just give that a second to finish. So that's creating the registry. It's actually creating a resource group that I can then use to deploy the rest of my app to. Handy tip here in the Azure portal, click on resource groups, and then you can see all your different apps that you've created. And there's that Stack Overflow app resource group that we've just created. And there's that container registry that we've just created. So as I mentioned, this is publicly available. Anyone can hit this, this URL. And so we just need to get the access keys so that we can authenticate with this registry using VS Code. So I select the access keys link menu option here. Here's a password. I'm going to click to copy. Let's go back to VS Code. And now we're going to start using Docker. So, oops. Click in the terminal, and I'll say docker login, so registry, azure.cr.io. It's going to suggest the username so registry. I'm just going to hit enter. That's the right one. Control V to put the password in. It's not showing you the password here. And then login has succeeded. OK. Now I'm going to build a Docker container out of this app and publish it to that Azure Container Registry. So I've got the Docker extension installed here. So I Control-Shift-P, again, to run a command. I'm going to run the docker build image command. And it's going to say what Docker file do you want to use. I'm going to use the one that's created with the app. And then it's going to want an image name. Now with a Docker image name, you need to prefix it with the name of the registry that you're going to publish it to so that people know where to get the container from. So I'm just going to add so registry.azure.cr.io here, put a slash. This is the actual container image name, and then everything after the colon is a tag. So tags are used as version numbers if you want to have production or staging, or just an integer version number. You can use that as a version. Latest is a good default if you're just starting out. So I'll hit enter, and that's going to take the files in this Docker, in this folder. It's going to build a Docker container out of it. And then we'll see that container actually available, and it's going to store it locally in the Docker service that's running on this laptop here. And we can actually see in this Docker extension on the left-hand side, oh, that messed with my terminal. We can see all the images that we have locally, and we can also explore registries that we have out there in Azure. While this is, okay, it's picking up there. Sometimes it's sleeping. Okay, so that built the image. And now if I expand the images here, this lets me see the local images that I have created in my Docker registry. And I can right-click on these. I can delete them. I can remove them. I can manage them. I can run them. I'm going to select push. And this is going to push this Docker container to that Azure container registry that I've just created. So you'll notice here there's a bunch of layers. All these lines here indicate a different layer of a Docker container. So Docker containers are composed. You start with a base image that someone else has created, and then you add your little bit of code in on top. And while this is pushing to Azure, I'm going to take a look at the Docker file, which actually defines those layers. And I'm going to explain to you a little bit of what I've composed here. So by and large, I'm using this base image that somebody else has created, this user on Docker Hub. They've created this container that's based on Alpine Linux, and it's got Python 3.6 installed. Right? So Alpine Linux is a very small distribution of Linux. You can get images down to only about 60 or 70 megabytes, as opposed to with using a full Ubuntu image, which is about a gigabyte in size. So smaller images means faster to push, faster to download, and uses less space on the server. Now, another important thing about this server that makes it actually a production-ready, production-grade web service is that image already comes in with, first of all, Flask pre-installed, but it also has an Nginx web server. So an Nginx web server does all sorts of things, efficiently manage sockets. It can cache HTML pages and things like that. And then finally, the Nginx server is connected to Flask using this UWSGI module that allows Nginx to talk to Flask, the Flask app I've created, just by a socket on the same machine. So all that stuff is very complicated, but somebody else out there has done the hard work for me. All I need to do is use that image, listen on port 8000, and then copy my code into the container. And that's really what I've done here. OK, so as I mentioned, I just published this container to an Azure Container Registry. Let's go ahead and look at the registries that I have sitting out in Azure. By the way, you can open registries on Docker Hub here as well. But for Azure, I'm using this private registry. So there's that registry that we just created. And what I can do is there's that image, the Stack Overflow Flask image. And when I expand that, that allowed me to see all the different versions or tags. We only have the one that we just created. So I'm going to right-click on this. And when I right-click on an individual container, I get this really neat functionality with VS Code that allows me to deploy this image directly to a new Azure App Service running in Azure. So I can select Deploy Image to Azure App Service. And remember, I created the Stack Overflow app resource group. I can just use that one. So it's going to ask me a series of questions here, right? Now it's asking me which app service plan do I want to use. So think of a plan as basically a VM. It's the actual physical resources that's hosting your app and app service. And you can actually deploy multiple containers to the same physical resource. You only pay for that physical resource, that plan. So you can have 10 different apps running on the same resource, which is especially useful if you only have, if you're just playing around with a few lightweight websites, you don't have a lot of traffic. This is a really cost-effective way to play with Azure. So I'm going to create a new app service plan. We'll call it the Stack Overflow plan. I'll press enter. Let's choose the B1 basic pricing tier. And then let's pick a name. We'll call this Stack Overflow, let's call it build. And so now VS Code, using that app service extension and the Docker extension, is going to create a new plan. You can see what it's doing here in the console. It's going to create a new website, set that website to pull the Docker container image from that registry, and then we can use it. So one final thing that I have to do, so this website is ready, but one final thing I have to do is I have to tell App Service which port my container is listening on. So I've exposed port 8000 here in the Docker file, so I just need to tell App Service, hey, you should use port 8000 when you're talking to this Docker container. So I'll go to the Azure tab in VS Code, which lets me browse my app services that I have published, and we'll be able to see this Stack Overflow build here that I've just created. I can expand that and see the application settings. So I just needed to add a new application setting, and I can do that by right-clicking here and saying Add New Setting. We'll say websites_port, and we'll set it to 8000. And now that that setting's been created, I can right-click on the website and restart it. After you change any settings, you need to restart the app service for that to take effect. And that was actually pretty quickly. It just restarted my site there, and I'm going to go ahead and right-click and browse that website in the portal. Now, the very first time you browse a site that you've created with one of these Docker containers, it actually takes about a minute to start up because it's downloading that Docker container image to that app service plan. Now, this is just a one-time thing because remember I said the Docker containers are all built in layers. So those layers actually get saved in the app service plan. So the next time I push, if I want to redeploy an update, it only takes a few seconds to load the site. So while this is there, I just want to share with you, I've actually published instructions on my GitHub account, github.com, Cubitron, Flask Web App Quick Start. Here I've got a bunch of Azure CLI commands that allow you to do all the things that I just mentioned. Here you can use the command line approach. What's nice about the command line is you can automate creation of websites or things like that. And I also have instructions here for doing this with VS Code if you want to follow along or have some documentation on the steps that I've just taken. So, and so you can, and this web app here is actually what I used as the base image for this Stack Overflow app. I just cloned this app, and then I added some files in there, the main.py and the data files. And there we go. Our app is now running out there on the web. If anyone's watching the video, you can go to this site right now, and I hope I keep it running to see all of the Stack Overflow language share over the past 7 years. Cool. All right. So just a quick recap of what we just saw. The first thing we did was we signed into Azure with VS Code, pasted that in the browser, hit continue. Then we created a resource group in Azure for our app and put a container registry in that resource group. Then we logged into the registry by copying the credentials and pasting it in the command line using the Docker login command. Then we used the VS Code command to build the Docker image and push it to that container registry. And then finally, we explored the registry with the Docker Explorer window and deployed that image to Azure App Service, and finally set the port and restarted the site.
Port 8000, that's only the connection between Docker and the website, right?
Yep. So the question was that port 8000, that's just internal to App Service. for the app service host to dock to the Docker container that you've just created. Externally, of course, app service will expose your website on port 80, right? Okay, so now let's take a quick look at how we can automate this using Visual Studio Team Services. So I don't want to have to manually take these steps every single time I update code to my app. Wouldn't it be nice if I can just set up Visual Studio Team Services to automatically build and push and deploy that container every time I make a check-in to my GitHub repo. So I've got a demo account here that I've created, by the way. I just created this with my Python demos at outlook.com. These accounts are free to set up. You can connect them to your Azure subscription. So I've connected this to my Azure subscription. And I'm going to go to the Builds tab here to set up a build workflow with VSTS. I'll click this New button to create a new build. And we can pull from multiple sources here. You can see I've got GitHub, GitHub Enterprises. I could actually have code inside this VSTS repo here if I want to keep it private. But as I said, I've got this code available publicly on GitHub. And if I want to set up a connection to GitHub, I can just put the GitHub URL here. Everyone's going to have my GitHub name burned into their heads by the time you guys walk out of here. Flask web app quick start, or sorry, wrong one. Stack Overflow - Flask. We'll click OK. And hit continue. And so we have a bunch of templates here that you can use to build your app. We're going to start with the container template here. So we'll click apply, and that'll go ahead and create a standard build and push task here. And the first thing I'm going to do is set this to run on this hosted Linux preview queue. So you can run one build job at a time with this free VSTS account that I've created. So and we can run it on this hosted Linux queue that's available to you. I'm going to go to the build an image build step here. And I'm going to customize this a little bit. All right, we've got our image name. So we need to make this match all the things that we've just done. So we have Stack Overflow, SO registry, azurecr.io/Stack Overflow Flask. And then it's going to put a unique build number tag on the end of that Docker container. So I can have all my versions saved so I can easily go back and roll back to a previous one if I need to. So that's going to build the image. Now we have a build task for pushing the image. We'll select our Azure Container Registry. I've got my Azure subscription wired up here to VSTS. If it's not connected, there's a button here that allows you to connect it. I can select that registry that I've created, and then I can tell it the image name that I want to push. Same image name using the same build ID. All right, so I need to do one more thing, is add a task here once this container has been pushed for it to deploy that built container to Azure App Service. So I can just add new build tasks here to click to add task. There's lots of build tasks available here, and you can actually create your own. There's a whole marketplace. Luckily, there is one down here for Azure App Service Deploy. So I'll add that build task. I need to tell it some information here. Again, deploy to my subscription. We need to set the web app to a Linux web app because we're running on top of Docker. And then we're going to pick the app service Stack Overflow build that we just created and fill in, again, the same parameters. So that's our container registry. And our image name is Stack Overflow - Flask. And then the tag is that build ID variable that we've created. So now that I've defined this, I can just hit save and queue. So I'll queue that new build definition. And then I get this link here that I can go look at. So it's going right now. It's pulling that code down. It's building that Docker container, and then it's going to finally publish to Azure. Looks like I'm position 1 in the queue. Okay, it's started. And you'll see here we actually get logs as to everything that's happening. And then you can see all the steps that are going to happen on the left-hand side. It's going to build the image, push it, and then finally deploy to Azure App Service. And just in the interest of time, I'm going to switch over to a completed build definition that I created earlier. And you can see that once it's been created, oops. You can see you get your success rate, you can see which branches, all sorts of information. Another neat thing that you can do with VSTS, I'm just jumping to a more completed version of this, is you can actually set up staging and production slots. And you can see here that the staging slot in this particular setup has succeeded. The production image hasn't been deployed, and I actually have the ability to approve or reject that deployment from my staging environment to my production environment. So in a more real, fully featured service, you would actually set up these different staging and production environments. And you can also set this up to run the Python unit tests as well. All right. So quick recap, you could set up a continuous deployment process with VSTS by creating a VSTS account, and then you can set up those staging and production slots. All right, so we're through the Python and Azure section of the talk. Now let's go and take a look at Python and Visual Studio. So Python and Visual Studio, it's a fully featured IDE. It's got a rich editor, IntelliSense debugger. It's got an interactive window. We have support for Anaconda, IPython in there. And you can actually use the Visual Studio installer itself to install Python and Anaconda and the different versions of Visual Studio. Because it's a fully featured IDE, you don't need all the command line things that I just did to do all the activities, for example, like managing virtual environments and packages. We've got a package manager window built in there. You can create new virtual environments. You can graphically install the packages that you want and switch between them. We also have integration with Visual Studio Tools for AI, so you can use Visual Studio Tools for AI to actually run training jobs, build TensorFlow apps, build CNTK apps, and actually train those using resources that you have in Azure. And the thing that we're going to be focusing on today is one of the best features or the best reasons to use Visual Studio for Python is if you're going to be mixing Python in with other code that you have, C++, for example, or C# code in Visual Studio. So in the time we have left, we're going to focusing on that last thing that we just talked about, the mixing Python and C++ together in the same solution. All right, so I've got Visual Studio open here. I've got, this is actually a C++ game using the open source Ogre game engine. We downloaded one of the samples from there. They have a C++ sample of an Ogre running around. And we've actually modified it a little bit to load a Python interpreter into the game. And we use that interpreter to actually script some of the actions in the game, right? So just, you can see here, I've got the C++ solution. And the only thing I've actually just gone and added these Python files into the same solution. Oop. There you go. Thank you. So I've got this solution open here in Visual Studio, and I've just got the C++ project. And you can actually just add Python files directly into C++ projects. If you want, you can also do file new Python project. If you have a bunch more Python code that you want to encapsulate, we've got support for all sorts of different project types here. So you can create all of your Python files in a Visual Studio project. If you want to just get started quickly with Visual Studio, you can just create a blank Python application and get started coding. But you can also just add these Python files into the C++ solution. And so I'm going to press into here. So what we've done is we've actually wrapped a bunch of the C++ objects using this PyBind11 module. So this PyBind11 module is a library out there that you can use, and it neatly, we just define a bunch of our C++ classes in here, and then we basically are defining a Python module that will basically wrap all of those C++ types. So we've got our game character, we've got different lights and shadows and things in the scene, and this basically creates, puts all of this in a Python module named Ogre. And if I go to this Ogre module here, I can see that I just import that Ogre module, and then from here I can define functions and various things that will actually manipulate the game. So one neat thing about Visual Studio is that we've actually got cross-language Python debugging. So if you're in the C++ solution and you've got the Python native development tools installed, you'll actually have this option here in the debug dropdown. So let's go ahead and take a look at this game. All right, and press play there. So again, this is the sample. It was originally developed to use keyboard controls to have this character running around. But we've gone ahead and written a Python script that moves the ogre character. All right, so this guy's name is Sinbad, and he's being controlled, look, no hands, by this Python script. He's running back and forth and doing various things. And we can see that this script here is, I've got a script here that has a series of steps that he takes. He runs, he's supposed to dance and stand, run backwards. But if you notice, he's not actually dancing, right? So let's actually go and use the debugger and go into the dance method and figure out what's going on. So I'm going to use Control-Click in Visual Studio. It's a nice keyboard shortcut for navigating to going to definition. I'm going to set a breakpoint within this dance method here. And we see, okay, the dance method's actually being called, right? And so now that we're at this breakpoint, I'll show you a few really neat things about this debugging configuration. You'll notice I've got Python and C++ code on the same call stack, right? And I'm in Python code, I can look at the self object here and see that there's a dictionary that says I'm going to dance for 4 seconds. And so all the Python debugging works as you'd expect. I can also double click on one of the C++ frames here. And this is where it's loading from C++ code. It's actually instantiating this Python module. Every single time it renders a frame, it basically calls into Python to say, what should I do? And then the Python code's controlling the game. Something neat here is now I'm in C++. I've got the full rich C++ debugging experience that Visual Studio has. I can expand. There's the PyBind 11 code that does the interop. And if I keep going, I can actually expand right into the Python view of this same module. So if I keep expanding here, I've got, this is showing me that Python module with all of the, I can see all of the functions that are defined in the Python module. So I can see C++ and Python code on the same call stack. I can go across the two variables within the same debug tooltips. You've got this really rich way to move back and forth, right? Okay, so as I noticed here in this method, there's a little note here that says Sinbad has to stand still before he can dance, right? So let's go ahead and uncomment that stand function there and see if we can fix this bug. So one of the reasons that this is a very productive way to work with a C++ game is that because Python is this interpreted engine, I don't need to sit here and wait for this project to rebuild after I make a change to it. C++ compilation can take a long time. And so if I'm quickly just want to play with some scripts and change things, I can just reload the Python interpreter, right? So I have this keyboard shortcut F5 that's bound to reloading the Python interpreter. And so it's going to reload that script. And hopefully our friend Sinbad here starts dancing. There we go. He's having a good day. Cool. Now, a few other neat things here. You'll notice that I've got IntelliSense on these C++ objects here that are defined. So I can type character dot, and you can see all the different objects. These are actually defined using a feature in Python called type hints. So I've got this ogre.py file here. Let me just show you this. This is sitting right next to this ogre module.h. And this is just some handwritten type definitions that we've created because IntelliSense isn't actually available for those C++ object types. You can create type hints in Python, then Visual Studio will actually use those type hints when it's populating the IntelliSense. So this is also useful for, if you've got dynamic Python code, for example, where the IntelliSense can't really know at runtime, until runtime, what's actually available. You can use type hints to provide a good, rich definition of your objects. And our IntelliSense will use those. And we actually have type checking built into Visual Studio. You can right-click on a project. Actually, it doesn't work on the C++ project. But you can actually run a command called, actually, it might work. Yeah, you need to actually be in a Python project for that. But you can run mypy on your Python projects if you actually want to check your Python code against those type hints. All right, quick recap. So we saw that you can actually host a Python interpreter in a C++ application. You can use PyBind 11 to wrap C++ classes and expose them to Python code. And then we have type hints in Visual Studio that allow us to provide IntelliSense over the C++ types. And then finally, the Python native debugging allows you to debug across those two languages at the same time. Now, if you want this support for Python in Visual Studio, you could just go to the Visual Studio installer, hit modify and select the Python development workload. This is all part of the Visual Studio package. And you can see there in the installer, you can actually select versions of Python to install. So you can pick the version of Python that you want. And then you also need to select that last option there, the Python native development tools, if you want the cross-language debugging to work. And we've published this code as a sample. This is published by a team member of mine. If you want to see how we've done or want a reference for how to use PyBind 11 to load an interpreter into your project. Just want to let everyone finish taking pictures. Cool. All right, so that was a big tour of getting productive with Python. We saw a ton of things in this talk, a bunch of features that you can use with Visual Studio, as well as with the Python language itself, so that you can, again, get a lot of work done, do some scripting, data science, web development, as well as C++ and Python development. For more information, we have a Python blog. We publish any updates that we make, any new features come out there. There's also links off to all our GitHub repos, all of our documentation. So go to that Python blog. You can follow me on Twitter, DanDTTaylor. And we've got Twitter handles both for Python VS Code and Python tools for Visual Studio that you can follow if you want updates. Please fill out your evaluations. If you guys like this session, please let me know. And I'm available for questions down here after the talk. Thank you.